You can bring this 3 out, bring the 4 out, right? Yes? So we have a half log. Do y'all see I can't do anything to this one? Because there's addition inside, I can't do anything to that. Here, I'm going to keep the minus, I'm going to keep the bracket. Let's bring the 3 out, 3 log x, and plus 4 log of x plus 1, right, like that. For that, I used property 6, right? 6 on this one, and 6 on that one. One last step, distribute the negative, we're done. So this will be negative, or not negative, 1/2 log of x squared plus 1, then minus 3 log x, and then minus 4 log x plus 1. There it is. So what you run into in calculus is that we're trying to do this thing in calculus called differentiation, or there's another in Cal 2, it's called integration. And it's really hard to work with things when we're trying to do that. It's hard to work with things when we have products and quotients. Multiplication division makes it really hard. So what we can do is we can use logarithms to rewrite something so that we have addition and subtraction between things. And it's very easy to do things in calculus when things are being added and subtracted together. So this is something, a tool that we use to help simplify problems later down the road, all right? Okay, so let me, do y'all want to see a problem that would be similar to one in a calculus class?
Yes.
Yeah? Y'all want to see one? Yeah? Okay. You asked for it. Okay. So this isn't any more crazy, it just looks a little different. You would get something like this. In a calculus class, you get something like this. Y equals, and then you get, I don't know, I'm just going to make this up, x minus 4 to the third times x plus 1 to the 7th times the square root of x over, let's say, x plus 3 to the 5th times the 4th root of x plus 2.
Solve for it.
Hold on real quick, I'm sorry. Good, I've got to do this real quick. All right. All right, so look. We have something like that in a calculus class, and we have to do something with it. It's really complicated looking, right? And there's a bunch of multiplications and divisions and powers and roots and all sorts of shit happening. So what we do in a calculus class, see, do y'all see any logarithms right now? You don't see any logarithms, do you? You can't just do this arbitrarily. You have to have logarithms to do this, right? You have to have a logarithm. These properties are for logarithms, not for just anything. So what we do in a calculus class is this. We take the natural log on both sides of this equation. So what I do is I'd write on the left-hand side natural log y. So I'm taking the natural log of the left side. And then I take natural log of this entire thing. So it's like I'm introducing a logarithm. I'm showing you this just to show it to you. I would not give you this on a test or anything. That step I wouldn't give you on a test. Now, this right here, that is fair game. I don't think I'd give you something that complicated, but why not? I mean, you're going to have to do that in a couple of semesters anyway, right? And they're not going to like baby step you into it. That's just like going to be the first problem they give you. So you got to know how to deal with logs. So do y'all see now I have log and I have division, right? I have division. So I can turn this into 2 logs with subtraction between them. So that's property 5. So from here, this is property 5, right? Property 5, this becomes 2 logs with subtraction between them. Right? It's 2 logarithms with subtraction between them. Now the top one, the first one gets the top inside, right? X minus 4 to the third, x plus 1 to the 7th, and then, can I write that as x to the half? And then over here, this gets the bottom one. So x plus 3 to the 4th, and then x plus 2 to what power? 1/4. 1/4. Right? Because it's the 4th root. Pardon? It's the 4th root. Oh, sorry. Yeah, thank you. I wrote 4 here instead of 5. Sorry, that's my mistake. That makes sense? But this logarithm has 3 multiplications, or 2 multiplications, right? 3 factors. And so I can use property 4 to turn that into plus 3 logs, right? It'll be a log plus another log plus another log. So I'm going to do that. This will become natural log x minus 4 to the third. What? Plus natural log of x plus 1 to the 7th plus natural log of x to the half, right? I'll bring the powers down on the next step. Any questions on that? Then I have a minus, right? Minus. And this is going to turn into 2 logs, isn't it? Because I have multiplication. So that minus will have to distribute through. So I'm going to put a bracket here. Natural log of x plus 3 to the 5th plus natural log x plus 2 to the 1/4. Close my bracket. Questions on that? Is it not so bad? Are y'all following? It's all right. Okay, now property 6. 3 comes down, 3 natural log x minus 4. 7 comes down, plus 7 natural log x plus 1. Okay, 1/2 comes down, 1/2 natural log x. Minus, the 5 comes down, natural log, forgot the 5. Minus 5 natural log of x plus 3. Yeah, so this is going to be a positive 1/4, but I'm going to distribute the negative now. So negative 1/4 natural log x plus 2. And yes, yeah.
In the parentheses, if two of them have the same, like let's say 3 natural log x minus 4, and the next.
This was also x minus 4 here.
Yeah.
You could put them together, and you would just let's just say for the sake of it, we had 3 natural log x minus 4 minus 5 natural log of x minus 4. I think that's what you're asking.
Yeah.
Then you would treat it just like this is 3 apples minus 5 apples. This would be negative 2 natural log x minus 4s. You just work with the coefficients. So you treat this almost like a variable. Like this is 3m minus 5m, right, would be negative 2m. That make sense?
Yeah.
Yeah. All right, and then back in the calculus class you do something, because remember this is equal to what? The left side, natural log y, and then you'd have to go and do something else. But this is, I just wanted you to see the expansion part. So we take something very complicated, right? And what we do is we rewrite it in something where it's just a bunch of things being added and subtracted, and then what we can do is we can attack these one by one. That one, then that one, then that one, then that one, that one. All right, stay tuned. Cal 1, you can do it there. Questions? Yes?
How do you know to do natural log and log?
Like why did I do natural log and not log?
Yeah.
Good question. Why did I do natural log? I can do any log. I could do any log because the property works for any log, right? So it was my choice to pick any logarithm I want. Now we wind up choosing the natural log because, well, that's the special one that naturally occurs, and again, you'll see what the great part of this function is later, but yeah, good question. I should have stated that. You could have used log, log. You could have done log base 10, or not 10, sorry, log base 4. But the natural log is the one that we prefer because, well, if it ever came down to it, we actually have a key on our calculator for natural log as well. So that's the one. Okay, I think we're good, I hope. We move on. What about the other way around? What about I give it to you like this, and you turn it back into this? That's called condensing. And we need to be good at that as well. So we're going to practice that now. And we'll start off with something pretty basic to start here. So if I write log base a of 7 plus 4 log base a of 3, base a of 3, we want to condense this. I'll put it up here, condense. Condense means try if you can to write this as a single logarithm, So instead of taking one log and ripping it apart, we're going to take multiple logs and put them together. So it's just all the properties backwards. That's all it is. So what I like to look at first is, are there any numbers out front? Because if there are any numbers out front, I'm going to push them up as powers. So you'll see the 4 here? I'm going to push that up. Log base a of 7 plus log base a of 3 to the 4th power, right? Isn't that what that means? That's property 6 backwards, right? That's property 6 backwards. Now, what is 3 to the 4th power? 3 times 3 times 3 times 3 is 81, isn't it? So this is really just log base a of 7 plus log base a of 81. Is there anything else I can do? I have 2 logs that are being added. So I can turn that into 1 log with multiplication. So this becomes a single log, but inside I have what? 7 times 81, which is 567, I think. Someone check that. Isn't that 567? Yeah. 567. We're done. We have a single logarithm, don't we? A single log. That's what we want. Questions? So from here to here was property 6, but backwards, right? This from here to here, all I did was that calculation. And then to put these two together into a single log, that was property 4, but backwards. Let's take a look at the next one. The next one is 2/3 natural log of 8 minus natural log of 5 squared minus 1. Yeah. Turn this into a single log. So I'm noticing something. Do you all see this? 5 squared minus 1. They're just being ridiculous here. 5 squared is what? 25 minus 1 is 24. That's just 24, right? Okay, so before we do anything, let's just rewrite that, because there's no need at all to have that written that way. That's just 24. Notice I put the parentheses around the 24 here, but not the 8. I can do it either way. I can leave the parentheses off, or I could put the parentheses. As long as you understand the thing that's going into the log, the argument of the log is 24. Here I have to have parentheses. Why do I have to have parentheses? Because this is not the same thing, right? This is not this. This would just mean the 5 squareds inside the log. The minus 1 is just outside. So this would be confusing notation. That's why the parentheses have to be here. But once I get it to a single number or single term, you don't really need the parentheses. Your choice. If I'm going to be consistent, I should put a parenthesis around the 8 as well. All right, what do you want to do now? Okay, 2/3 first. 2/3 push it up. You can't do this yet, 2 logs into 1, because this is not just a single log. It's 2/3 of a log. You have to push the power to the top first. So this is going to be natural log of 8. I'm going to write as 8 to the 2/3 minus natural log of 24. I'm going to write it this way just so you can see the 2 different notations. They mean exactly the same thing. Now you have to figure that out if you can. Do we know what 8 to the 2/3 is? That's the same as the what root? Cube root of 8 but then all of that squared. That's what that means. We talked about this, yes? Way back in the beginning of this class. We were talking about radicals. So what's the cube root of 8? Careful. We're not taking half of it. We're saying what number times itself 3 times gives us 8? 2. Oh, you're saying the final answer is 4. Sorry. Okay. So the cube root of 8 is 2, and then squared is 4. So this is just 4, right? Natural log 4 minus natural log 24. All right, we're almost there. Two logs with subtraction. That can become 1 log with division. Now, when you do the division, the order matters, right? What goes on top? 4 goes on top, bottom, 24. Now, that's a fraction. You can try and reduce it if possible. 1/6. Natural log of 1/6. Natural log of 1/6. Questions? Now, this will happen to you. You'll be doing, I hate that I always talk about calculus. It bothers me, but y'all can tell that's all I do is teach calculus. I mean, you can tell, right? I mean, because this is a benefit to you, though. I think it's a benefit because you could be in a class where your professor doesn't teach calculus and they have no idea what you're going to see. They know how to do the algebra, they know, but they don't know what you're going to see later. So students will get frustrated because they'll do something in calculus, they'll get an answer like this, and then they look in the back of the book to check their answer and they see this and they think they're wrong. Is that the same thing? That's the same thing. Why is that the same thing? Because you could rewrite this if you wanted to. You could rewrite this as natural log of 6 to what power? -1, right? Isn't that another way you could write 1/6? 6 to the -1? Then you could use property of logs and you pull the negative out and you get this. That's weird, right? But these are the same thing. So when you see things like that down the road and you're like, man, my answer doesn't look right, just remember these properties can be written different ways. This is a correct answer as well as this. They are equivalent to one another. All right? All right, we move on. No, more examples. Sorry. Oh, I really like this example because there's a lot to it. There's a lot going on. Log base a of x plus log base a of 9 I'm deciding if I want to make this harder than it is there. No, I'll just leave it. Plus log base a of x squared, or x squared plus 1. And then minus log base a of 5. I should mention that if any of these logs had different bases, the properties are not valid. So if you had like log base 4 and you had a log base 5, you can't put those together. Okay, you can't. They have to have the same base. It doesn't come up that often, but just you need to know that that's, you have to have the same basis for these properties to work. These all have the same basis. All right, so I'm looking around here. I'm looking first to see if I see any numbers out front that I can push up to the top. And I don't really, right? There's like a 1 here, 1 here, 1 here. Negative. There's a -1 right there, right? I don't want to push a -1 up. What I'm going to do instead is when I get to this, I'm going to look at it as the subtraction becomes division. That's what I'll do. All right. So, what do you want me to do? You can go like one piece at a time, or take your time with it, or try and do it all at one time. We'll go slow. Can I put those two together into a single log? Yeah, I have addition between two logs, right? Okay, put that into one log. It'll be a single log, and inside of the log I'll have what operation? Multiplication, right? And I'm going to be multiplying what together? X and 9. Isn't that just 9x? Right? That's those two together. Now I still have here log base a of x squared plus 1, and then minus log base a 5. What property did I just use? I think that was the fourth one, wasn't it? Fourth property backwards. Fourth property backwards. Now what? These two again? Like we can do it again? Is that what you were saying?
Oh, no, so you can put -4 for the thing. 'Cause it's the
Oh, the back, yeah, I could do like an inverse. Oh, I could do like, no, I'm not gonna mess with it. Okay, can I put those two together?
Yep.
Yes, same property, right? Property 4 backwards. So a single log, right? A single log, inside that log, it will become this times this, right? This times this. Now I'm not actually gonna multiply it out, I'm just gonna put them next to each other. But you could distribute this through and become 9x cubed plus 9x. I could, I'm not going to. Minus log base A of 5. That was property 4 again, backwards. Now what? The division property, right? Because we have two logs being subtracted, those can come together to a single log. So I have log base A, and now I will have division, won't I? The numerator will be the 9x times x squared plus 1, and the denominator will be what? 5. And I'm done. I have a single logarithmic expression. Did I forget something? Oh, I don't know. Sorry. A, log base A. Sorry about that. Just checking you. Make sure you're paying attention. All right. All right, you ready for a new formula? I've given you all the properties, right? Those 6 properties. Now we have a theorem which gives us an extremely important formula. That's really, this formula right here is going to be the thing that allows us to use our calculators to solve all logarithms. It's called the change of base formula. So we're shifting gears here. We're going to something new, this theorem. It's called the change of base formula. Here's what it says. Put like several stars next to this because you need this a lot. Okay, if you ever have a log base A of x, if you're ever trying to figure out what that is, okay, you're looking at it, you're like, what the hell is that? Here's what it is always equal to. It will always be equal to the natural log of x over the natural log of A. And that's it. That's the formula. Let me give you an example next to this so you can see this formula in action. If I write down this expression right here, log base 2 of 8, let's go back to last class, which was last week, which I know maybe you don't remember, but this is asking you a question, isn't it? This is saying, hey, if you take the number 2, what power do you raise it to get 8? The answer should be 3, right? The answer to this should be 3. We can tell just by looking, the answer to this should be 3. We can double check it with the loop, right? 2 to that, 2 to the third is 8. Check, right? That works. But let's act like we don't know that, right? This is what I want you to see is that this is saying that number raised to that, sorry, that number raised to some power must be that number. So when I see this, it's saying that number raised to some power must be this. Well, if you want to figure out what the answer is, all you have to do is this. Now, you look at that, you're like, well, what the hell? That's just, it's more complicated now, right? Well, here's the beauty. You have this natural log key on your calculator, right? So what I'd like for you to do is let's get this answer. We know the answer is 3 here, right? But let's get our calculator to give us that answer. So what we'll do is we'll write this down, log base 2 of 8. We're trying to figure out what that is. And according to the change of base formula, right, this should be natural log of what over natural log of what? 8 over natural log 2. So on your calculators, which I hope you will all start bringing from here on out, right? I told you all that already, though. Bring your calculators. You want to do natural log of 8 on your calculator divided by natural log of 2. And I need everyone to make sure you can get that answer and type things in properly. Be careful, you are not doing this. You are not doing the natural log of 8 divided by 2. You are not doing that. All right? It's two separate natural logs and you divide them. So a lot of your calculators, you should be able to just type it all in at one time. Natural log of 8 divided by natural log 2. How many of you that have your calculators are getting 3? Yes? Anybody getting like 2.999 or anything like that? Or 3.0001? Sometimes the calculator's round and it messes things up. Okay?
Just change it to like radical.
How do you mean?
Like a calculator, you can change it to radical or.
Like fraction decimal?
Yeah, the degrees. Radians.
That won't change it. Radian degree won't change that.
It changes your size.
So look, this right here, this formula is super powerful. Because watch, what if I gave you this problem? What if I said log base 2 of 7? Now I'm saying to you, what do I raise 2 to? What power do I raise 2 to? That doesn't make sense. What power do I put on 2 to get 7? Right? That's what I'm asking? Well, here it was easy, right? 2 to what power is 8? 3. But 2 to what power is 7? Shit, I don't know. But this does, right? Let's do it. This is going to be natural log of 7 divided by natural log of 2, which is, it's going to be a decimal. We'll have to round. But I'm getting 2.80735. And yes, I'll have to round, okay? I'll have to round. But that's the power I'd have to raise 2 to get 7. And you could double check. You could check your work by taking 2 on your calculator and raising it to that power. And I'm going to stop at the 5 here. So if I take 2 on my calculator, I raise it to the 2.80735, I get 6.999976118. So it's close, right? Again, we're going to have some rounding errors, but that's okay. Students will tell me, well, we have this rounding error, that's a problem, Look, in the real world, right? If you're an engineer and you're building something, you can only build something within a certain tolerance anyway, right? If I want to cut a piece of wood to be exactly 2 feet, do you think I can get it exactly 2 feet? No, I'm going to be off by, well, it depends on how accurate my measuring is, right? So we have this plus or minus tolerance in everything that we do. Even if you're building an aircraft ball bearing at high precision, where it's within thousandths of an inch, it has to be correct. There's still a plus or minus. There's still some error. And then you factor in just like heat, expansion, and contraction, right? When something's hot, it does what? Expands, and when it's cold, it contracts. So if you measure it when it's hot, it's going to be one thing. You measure it when it's cold, it's going to be something else, right? So what's correct? So the rounding is not a problem for us. We're always going to be within some sort of window. Y'all seemed very, very quick on that response. When you heat something up, it expands, right? And when you cool it down, it contracts. Is that true for everything? No? What's the one thing that you can think of that doesn't do that? Water. Okay? How many of are y'all familiar with the idea that we heat something up, it expands? And when you cool it, it contracts?
The air goes out and the ice goes out. So
The water's opposite, right?
Yeah.
When you heat water, it actually becomes smaller, and when you cool it, it becomes less dense. And that is why life exists on this planet. If that didn't happen, life wouldn't exist. And here's why. Think of like a lake, right? Think of a lake, right? The heat from the center of the earth, right? The heat from the center of the earth. Of course, you got sun too, but the core of the earth is hot, right? There's warmth in the core of the earth. So when we freeze water, right? If it did what everything else did, then when you freeze it, it would fall to the bottom. It would sink. But it's not that. When we freeze water, what does it do? It floats. Okay? So what happens is you got all this life, right, in the water. That's a fish. That's another fish. Okay? You got all this life living in this little pond or lake or whatever. And when it gets really cold outside, what happens? The top freezes, right? The top freezes over. And you get this layer of ice on top, not on the bottom. And what that does is it creates a thermal blanket, and it actually keeps the heat from the earth down here, keeps the heat in the water and it keeps the bottom from freezing and the fish live. If water was the other way around, then what would happen is you'd have your fish here. My fish are getting worse and worse. And as it got cold, you'd start developing ice on the bottom, but then there would be nothing to keep heat in. So it'd just keep icing and icing and icing, and the whole thing would become a solid block of ice, and then everything in there would die. So if water didn't do that, there would be no life on the planet, which is kind of an amazing property of water, isn't it? Okay. I seem more excited than you. Okay.
I mean, it expands when it heats up too. It turns into a gas.
Well, yes, it does when it goes from state to state, right? When it changes states, it can do different things, but it behaves very different than like a block of steel does. All right. Change of base formula. Awesome. Yes, we love it. Okay, so let's do these two problems that they have us. These are just calculator problems. Log base 5 of 89. I want you to do that one. Let's do log base root 2 of root 5. And then I want you to do this, log of 12, and then natural log of 12. And I'm going to show you on each of these how I'm going to do these on my calculator, right? This first one's pretty straightforward. Natural log what over natural log what? 89's on top, 5's on the bottom. Isn't that easy to remember too? Because the 89's up here, the 5's on the bottom. So you just do it like that. Natural log 89 divided by natural log 5. Approximately 2.78889. We'll round, I don't know, 3 decimal places. That'll work. All right, this one is just going to be a little harder maybe to type into your calculator. Natural log root 5 over natural log root 2. A little more challenging to put in here, but again, that's why you have your calculators, because you can practice. Natural log, you have to find your square root key. Already screwed that up. All right. Who's got an answer for me? 2.322. Let's go with that. 2.322. Approximately 2.322. If you're not getting those, get with me after class. I can help you out. How about this one? What am I going to type in my calculator here? Well, it depends on if I have a log key. Some of you actually have a log key on your calculator as well. I know this one does. This particular calculator has both of the special functions. It has the log and the natural log. So if I had this calculator, I would just type in log of 12 and be done. When I type that in on my calculator,